Oh, good morning, everyone. And we're live. Yeah. So, what is it that I want to do today? Today, I think the plan is to review this four commits, and in an effort to understand how to integrate how to integrate FreeRTOS into your bare metal project, and kind of what you need to take care of and what you need to be aware of as you do this. Um, I wrote a short primer on what FreeRTOS is a couple of days ago, and also as you're setting up FreeRTOS, you'll need to select a hit management um, option, and this is something I also wrote about, and you should be able to find on my notes. Let me let me just uh, share that I have started my. I just want to share that uh, I started my thing, my review, so that people can come. Let me just let me stream stream um RTOS free RTOS integration to bare metal project review. Yeah. Uh, who's this? 95. Okay, cool. Okay, so if I recall correctly, last time when we were trying to do the FreeRTOS integration, we couldn't get the build to work, and we couldn't get the build to work because if I remember, we couldn't get it to find some of the files that we needed to find. All this came from issues with our makefile, and usually, so there's many ways of adding, like, okay, C. There's many ways of adding libraries to C projects, and depending on whichever tooling you're using, so say what build tool you're using, what build tool you're using, what IDE you're using, sometimes you add libraries in a different way. However, in this effort, I wanted to try and add libraries using CMake, which is the kind of the base library thing for C. However, you can. I'm sure there's lots of other options that we can use, but I wanted to use CMake so that you could take this information and take it and apply it in your own project as you deem fit, and such like options. Cool. So I'll just walk through. I'll do a review the normal way I do a review. Although this is a committed review already, so it could have been. Maybe I'll start opening pull requests to this project now that we are like, I think we're 40 or 50 commits in, and we're starting to have stable features, and we kind of have an idea of where the project is. The board bring up has been done. We've added RTOS to the project. It's working okay. Some tasks are already defined and they're going okay. So I think that now would be a good time to start adding testing to our project. However, that is for a later juncture. So along with that, I can start writing code as in form of pull requests and start like documenting efforts to write code in pull requests as issues. So if you do have any issue that you want me to implement, you can add them to this list. And and once you add them to those lists, we'll see how we can work with them. There's a group of us that are working on this project, and I'm sure we can all accommodate what you need. So let's look at adding FreeRTOS and what that involves. So the first thing you'll need to do is you'll need to go to freertos.org, freertos.org, I'm assuming this is something you can figure out, but then you'd need to do something like download FreeRTOS, which is this option. Amazing. And then the next thing is once you've downloaded FreeRTOS and you have that on your machine, I think it will be in documents and then embedded. If this is embedded, it's gonna FreeRTOS somewhere. Okay, cool. So this is a folder you'll get, which is a collection of the source of FreeRTOS, and then the source of FreeRTOS Plus, which is um, all the other third party and additions that come with FreeRTOS. But for today, we're just going to focus on the base FreeRTOS layer. Cool. So you've downloaded this, you've gotten it to your machine. You have the source over here, which is the source of FreeRTOS. This is what we're adding. This is the library itself. This is what we will be adding to the application. And then you'll have demo here. We are running on a Cortex M4, Cortex M4, if possible, STM32, M4F STM32, something like that. So let me extend that, see if we can get STM32. What's you? No. M4F. It's gonna be M4F, not that one. 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 Sorry. Not that one. Not that one. I think it's an IR project, maybe. Oh, come on. No. Yeah. So this is STM34, STM32F4 with a floating point unit, and in here we'll find we'll find stuff that we need for our specific application. So we'll find a FreeRTOS config.h that we can use, and we also, which is what we'll use later. And what else do we need from here? That's mostly it. This config.h. And is there anything in board? No. Config? No. Kemptis? No. Settings? Setup? That's all we already have all of that. Cool. So from here, we'll get the configuration that we're going to use. Okay. So once you've downloaded this and you have all the sources on your machine, you're able to you at the high level, you'll be able to follow along this video if you were indeed doing a FreeRTOS integration. So let's look at what is involved. So let's look at the first copy. Modify CMake for FreeRTOS sources. So what we need to do here is modify CMake so that it can identify what source files to use when building the FreeRTOS library. Last time I tried to add FreeRTOS in such a way that we could just build the whole project at once. Like the library would be built and linked in at once. But as I did that, it became more difficult to do. So what I ended up doing was I ended up adding a FreeRTOS folder, which is this one. And then in this FreeRTOS folder, I defined a CMake list. So this is just one that builds a library of FreeRTOS for us to use later down the line. Okay, cool. So that was the first thing we need to do. We need to modify the project CMake list, add the FreeRTOS sources, include the directories that we need, and then add the sources to the target. Okay, cool. Then we need to modify our project STCMake. So this is first of all, let's look at the first changes. So in our whole project, let's go to CMake list here. Add FreeRTOS source files. Add add FreeRTOS include directories, and then we can add FreeRTOS sources to the target. Okay, cool. And then in our STCMake, if anyone has a question, you can feel free to use the YouTube comments or whatever. Okay, cool. In our STCMake, where's the CMake folder? Here is the CMake folder. In our STCMake. The other thing we needed to do was add these two. So that's the source to include and the portable layer. All of this is explained in the previous video. And if I recall correctly, that is all that we needed to do. Yeah, that's good. So once you've modified your CMake to include FreeRTOS and to add FreeRTOS as a library to your executable, you're good. That's the first beginning step. Okay, so what's the next step? Adding FreeRTOS to the project. This is basically what we saw. So this has a lot of file changes, and I don't want to show all of them, but what we basically did is added the FreeRTOS sources and include files into our project. And once we added all of this into our project, and we had done the CMake stuff, it could recognize them. If that makes any sense. So this is just copying the library in. This is in in uh, in Node. This would be something like npm install or something. You know, when npm install, it will pull down the library and put it in your. Oh my god, it's been so long since I've written JavaScript. It will pull down the library and put it in your Node modules folder. So the us adding FreeRTOS, us copying these files, the sources, this one's the source, and the portable layer into our application. Us us copying those files and using them is basically makes it so that how do I explain this? It makes it so that we can use the library. I need to know if my headphones are not. I'm sorry. The audio can be quite broken if I'm not on my headphones or quite low. Feels like I'm mumbling sometimes. Let me just look at my OBS. Mic aux. What are you using? Hello. Okay, it's fine. It looks good for now. So these are the sort of things content creators do quite easily, but I'm not a content creator. I'm a developer who's trying to become a content creator. Okay, cool. So that's the first thing. We have CMake working, and it's adding the library to our project. We have the library in our project, so we now have the library inside our project. However, at this point, if you do try to build your project, um, what you'll notice is you'll have a few errors, and some of these errors will depend on how far along your project is. So, if your project already implements a sysdig, as ours already did, so if you look at our project, and if you remember a few weeks ago, we did a timer driver, a delay timer, which basically we set up a 10-minute and in 10-minute, that's the source. Let's look at the source itself. Okay, so we set up a driver, and then every time our sysdig handler was run, we would update the timer, and that way would run like a delay that we could use a number of times, a non-blocking delay that we could use sporadically around our project without affecting the rest of the thing's timing. Okay, so number one, if your project already has a sysdig implementation, whenever you do build, your thing will fail. And it will fail due to the reason that there's already a sysdig implementation. What you would need to do is probably comment out or delete your sysdig, and in place of it, you could there's an application tick. So let's look at the FreeRTOS config. So there's if you have this configuration, config use tick hook. Okay, config use tick hook. Config use tick. Um, so let's see. Config use tick hook FreeRTOS. Every application does not. Okay, so cool. So config use tick hook. Where is my FreeRTOS configuration? FreeRTOS configuration instructions. I'm doing this here so that you can see where to find the thing you need when you're doing it. That's cool. Which is the whole point of this of my vlogs, to show how to find the information. I do not want config use tick tick hook tick hook. Okay. The whole point of this thing is for you to become a senior developer. I read a thing today and there was like senior developers get caught. We get caught making mistakes. We get caught looking up stuff. We get caught not knowing. And basically, the moral of the story was like, go into the situations where when you don't know, just say you don't know, but also be willing to find out. And the more you're open with yourself not knowing and saying not knowing, I just discovered this or I'm just working on this, the more you're showing others that that's what they need to do. It propagates along. So, anyways, config use thook. Let's look at thook. So thook is a callback function that runs if you have some admin stuff, you know, and you have admin stuff, um, and you can like in our former application, we had well in our current application. In our current application, we had why is it not okay? Why is it not? So we had in my delayed timer. Let's see. We had an implementation that was using Systic handler, and we were doing some cleanup there. We were doing some task switching there. Whatever you're doing in your Systic handler, whatever you're doing periodically there. Now this can be moved into your tick hook function, and in your tick hook function, you can do all the admin that you were previously doing in your Systic handler. Okay. So for us, this would be commenting out this or deleting this, and then in our main folder, in our main module, we need to provide a function that says this is an application ticket. So returns a void is defined by the application. It's a tick hook. Okay. Remember, we did names and oh, I think it was something. It was you can find how to interpret this information in this document, which is a primer. It shows you how to V task, X task, PV stuff. If those are if those little annotations on top of function names and variables mean something. So X task means something, PC task means something. And if you understand this, suddenly you decipher quite a lot of this code, and you can understand why it's named like that, what it's doing. But here, look. So we have an in our tickhook, we can apply our timer update that we were applying previously before. Okay, and we can do whatever we needed to do before. Okay, so this is functions that are periodically run as needed. Now, in this situation, I would probably remove my implementation of this delay timer and use the timer that comes with FreeRTOS. We'll look at that somewhere down the line to implement the delays I need to do. But in general, it would be a more complete implementation of this timer itself. So it's not so you have you initialize the timers, which usually will happen probably when we start the a FreeRTOS scheduler, and then whenever you need a delay, you can start a delay and you can check it whether it's done or not. Okay, cool. So that was the next commit on remove extra sysdig, and we implemented application hook and application stack overflow hook. And all these hooks can be enabled or disabled in our FreeRTOS config. Okay, so if you're using an idle hook or a tick hook, or you have a stack overflow hook, or yesterday I was writing about something. You can also have a malloc. Well, where's those notes? Let's look. Let's look. So yeah, where's that? So if your application fails, okay, we can have malloc fail somewhere. Yeah, malloc failed hook. There's alloc memory allocation failed hook, which is also defined here. Here, memory failed hook. Usually, when you have some dynamic allocation going on, and that dynamic allocation fails, um, usually we end up with a fatal error. So you'll crash the program, or the program will crash because you have undefined behavior. You've just allocated some memory, and that allocation failed, so you can't go on do what you need to do. Okay, so usually you can't just fail, but if you don't want to just fail, what you need to do is to configure the use of a memory allocation failed hook. And whenever your memory allocation fails, um, fail gracefully. So fail gracefully would mean something like don't just crash. You could crash, you could reset the system, you could defragment your system. Like, look at, you you could have a memory allocation failure, and then with FreeRTOS, you could look at the memory structure, see if is it because of fragmentation, is it because you use too much memory, is it because you can find out why this failed, and depending on that, some of those failures could be recoverable, and some of those failures might not be recoverable. So, and choosing which failure to apply in which situation is what is would be known as failing gracefully. So you can use a malloc failed hook to fail gracefully in case you're out of memory in a situation where you had an allocation that just failed. Cool. So what was the next thing? So as shown, so we commented out cystic. Yeah, we commented out cystic, and then sysnit, move some I squared C stuff to a different place so that we can use it. My commits are not clean. Yeah, this is actually a good place to explain this. So my commits here, this is actually not such a bad one, because my commit also explains what I was doing and get code compiling again. My code might have been not compiling because of positions of functions, and I was doing something before something else or after something else. Um, Ideally, you want small commits that do very direct one things. This huge commit that I just did was like a kitchen sink, like, oof, this is all the code change. This fixes my application. Please, let's do it from here. This is acceptable in very early stage projects like mine, when you're doing prototyping or when you're just setting up the base. But the farther along you're going into your project, you have to consider writing commits or doing changes very specifically. So, like, right in this change, I would have just commented out sysdig and moved it to application hook. But that should have also probably come with the enabling of the application hook in the FreeRTOS config. But since I copied a FreeRTOS config that was being used elsewhere, or rather the one that comes with the demo, I needed to comply to that config rather than set it up. And if you want to set up FreeRTOS by yourself, be sure to look at this document. So FreeRTOS configuration and customization of configuration. Okay. So look at this, read all of this, see what you need, use it as you need. Okay. So that gets us to the next commit. So what's the next commit? Please be a team. So first of all, here you see we introduced an application take hook and the stuff that we were using, custom stuff we were doing while the application was taking, we put it there. We put a Stack Overflow hook for reporting whatever overflowed the stack, and we can use that later. Okay, cool. I can remove this because I'm not using it, and I did intend it for it to be here, but because it's here, I'll explain it, and that's good. Okay, cool. So let's look at the next thing. So what was the next thing that we did to get it to compile? Remove extra stick, add missing application hooks, and now the application runs. Cool. So I added the relax. So I added the sysdig and I added some prints in here, and then I added malloc failed hook because that option is enabled. The reason I'm adding hooks sporadically, it seems, is because I'm using FreeRTOS config that comes from the demo folder. So if you look here, at demo, and we go to the Cortex M4 STM32F4F4F STM32F4F M4F STM32F407. Cool. We go here and we look at this FreeRTOS config. We'll see console. Can I just open that like that? Yeah, you see this is already set up to something else. So when I took this file, I committed to these settings and I didn't want to change it over. So this is most likely you will start by copying this one. Okay. And of course I changed my compiler. I'm using GCC GNU. So if you look at my code, here, you'll see I'm using the GNU compiler. Yep, yeah, not the IAR compiler, and this includes system call clock differences. So cool. Okay, so that's the beginning of that, and we've gotten that explained. Cool. So, and that's the reason I sporadically added so many hooks. So I added a malloc failed hook because that was already set. And then I added an idle hook because that was already also set up to be needed. Okay, cool. So with those four commits, my FreeRTOS application is running, and I'll quickly demonstrate it for you now. So cool. Here we go. I am invoked. Application tick hook run has been run. Okay. We are in idle hook. Okay. So let's look at a couple of things. So we know when application tick hook will run, and we also know when let's look at idle hook. You can use an idle hook. Okay, so an idle hook. What is an idle hook? Idle task. So the idle hook gives us the idle task, and the idle task is the task that runs when nothing else is running. It's like the pause task. When your microcontroller is just waiting for stuff to come, or for messages, or for information, you could be in many states. You could be in a busy wait, which Umesh covered in the DevHeads. I'll link it in the description. You could be in a busy wait, which is just you're just spending cycles waiting, or you could go into some more efficient ways of waiting or idling would be to use something like wait for instruction or wait for interrupt or wait for exception hook. And with Kimsys, you would do something like underscore underscore WFI. Uh, okay, so this you would use WFI content. So so this is an instruction that basically does what? WFI. Yeah, is a hint instruction that suspends execution until one of the following events occur: a non-mask interrupt, an interrupt masked by primers, a debug entry is requested. So you could make your system sleep and wait for interrupts or exceptions. Okay, that's another way of waiting. Another way of waiting is to have a task. We'll cover tasks next, but tasks are basically the easiest way to explain them is functions that never return and that are run in a infinite loop. So it's run top to bottom, and then it's run top to bottom, and then it's run top to bottom, and it's run top to bottom completely. So assume some situation where like you have a function that goes, if you had a function that does this. So let's look at. Uh, so if you had a function that did something like while one print print f I am infinite. So what would just ignore my code error at the here. Cool. So what would this do? It would just go, it would just go on a cycle. I am infinite. I'm an infinite. I'm infinite. It would just keep running this. Okay. So that's what a task is. So in FreeRTOS, we have an idle task, which is a task that should be run when all other tasks have been run and the processor is just waiting. So you can use this task to do the way I would use it is I would do low priority work. I would do logging. I would do defragmentation if I could. I would do I would do any health checks. I would do any pings and such. Um, if I need to compose, if I need to do some sort of machine learning stuff, or like I need to uh, process some machine learning data, I would do it in the idle task because I would wait for all my important stuff to be done, and then once my all my important stuff is done, while I'm idling, I will do that work. Okay, cool. So the idle hook provides us an opportunity to do low priority work um, that we need. Okay, so we have an idle hook which will run when we have an idle hook which will run when we're idle, and then we have a tick hook which will run whenever we have a tick update. Okay, cool. We also have a memory allocation failed hook, and we also have a stack overflow hook. We'll look at this later in depth, but for now we won't look at them. Okay. So what we want to look at is the idle hook, and the next thing is the what we want to look at is the idle hook, and the next thing is the tick hook. So just to make sure that we are running FreeRTOS. Okay. So my code is a mess. There's a lot of initialization and such. However, give me a couple of weeks as we do these streams. We'll break this down and move this application from being a majorly bare metal application to being a FreeRTOS application that uses tasks. And later we might do the same for Zephyr application. Cool. So that explained. Cool. So All I need to do for FreeRTOS, remove that. All I need to do is to start the FreeRTOS schedule. So let's look at some docs. Um, so yeah, all we need to do. Let's go to the end of this. Okay, so we need to. You see all this PRV. So PRV is private. This should be functions that cannot be called from outside. Set up hardware. All these things I'm doing where I'm setting up some hardware. I'm initializing the system and initializing the timer. I'm configuring the time team 7. All this stuff I would do all of this stuff in private setup hardware. We'll use that next time. Okay, and then once we do that, we need to create tasks. And tasks are functions that don't return. We'll get to this. They're not the biggest things that we need right now, but we'll get to them. Right now, let's just get FreeRTOS running, and once we have a version of FreeRTOS running, it's okay. Okay. Uh, cool. Once look at this. Look at this. So once we start the FreeRTOS scheduler, it won't exit the FreeRTOS scheduler. What does that mean? Any code that is after this. So if we go to our application, if we go to our sample application and look here. So once we start the FreeRTOS scheduler, all of this code, the blue LED setup and all these delay timers, and even this while loop that's down here, they'll never run because this code will only run if FreeRTOS failed. Ideally, we would convert all of this functionality that we have in here into FreeRTOS tasks and then set up those tasks before we set up our scheduler. And once we start our task scheduler, it will let it run. However, today, what we're going to do is just start the task scheduler and hope that the task scheduler, when started, will invoke our idle our idle hook because we will get to idle. There's nothing we don't have tasks, so we don't have tasks, so nothing. We will be in idle all the time. But then we also have a periodic timer update that is going to run every time sysdig runs. So between these two, we should be getting at least logs of them both. So let's see if we can run this. If the demo goes out with me, start debugging. I want to use Cortex debug. Then stop, run, start debugging. Please don't fail. Please don't explode. I hope I fixed everything. Yes, I did. Okay, cool. So I'm going to look at the ITM output and let's look. Let's see what happens. Ah, okay. Stop. Okay, so let's go to the top and see what happens at the beginning. Actually, stop again. I want to remove all the. I have some breakpoints, so just give me a moment. I have a breakpoint in I squared C. So what I want to do is come to. Okay, I know what I need to do. I know what I need to do. I know what I need to do. Go to main, and then let's stop at. Yeah, let's stop at idle. Okay, run. Start debugging. Okay, so cool. So we had Sysint, we'll run all of this. What you'll see is we'll get all this code, all these printfs that are before we start the scheduler, and also some from here, which is sending. And then once we start the scheduler, we'll get the ones we need. Okay, cool. So let's run it. Okay, cool. So you see, we are stopped in idle. Okay, so the processor did a lot of work, then it stopped in idle. Okay, we play again, we're in idle again. Play again, we're in idle. But look, we are in idle, and then application tick hook has been run. So what do you notice? So application tick hook was run, and we're back in idle. Play again. We're in idle. Play again. We're in idle. So what do you see? Our free art. What this demonstrates is that FreeRTOS is running. Okay, and it's now running properly. We have our tasks running. We have our hooks running, and this enables us now to use FreeRTOS as we need. Okay, so this is all the code you need to set up FreeRTOS as a library in your application. Now, from the next FreeRTOS uh, streams, what we're going to do is we're going to break down this bare metal application and make it into tasks and make those tasks run so that we can run the same application that we were running previously. I mean, we'll probably like do a checkout of the application before we added FreeRTOS and run it. And then after we added FreeRTOS and run it, and we'll see what changes. And what you will notice is it will be the same application running under the same hooks, but just laws applied for FreeRTOS. And additionally, we'll have these hooks and we'll have the FreeRTOS features that are coming along down the line. Okay. And this will enable us to divide our work into things called threads, which can be synonymous with things called tasks. However, I don't want to dive too deeply into this and kind of jump the gun, if I can say it so. Okay, one last thing about FreeRTOS. So there's a few, and I'll probably let's add them, and then we can explain them next time. So our run configuration launch. Okay, so this run configuration can be modified to support FreeRTOS. So what do? We will add RTOS, yeah, and then this is FreeRTOS. Okay, cool. And then here we will say FreeRTOS free RTOS RTOS config. Okay, so this is a configuration to use when we want to how do I say it? When we want to debug FreeRTOS, okay, from Cortex debug. Task list NDR. So this is the list of tasks. Task. What? Why is that? Why is that not working? List DR. Okay. Let's X. No. And X. UX unsigned task get all run time counters. Okay. Huh. Okay. So I won't do this now because this is going to be confusing. I do not want to leave another how do I say this? I do not want to stop another stream at a broken point and have to go off and debug. Might have to because I've already done it now. But what I what what I want to yeah, let's see. Yeah, yeah. So here you go. Basically, what we just did now is we added we made FreeRTOS task aware, and it can show us the tasks that we are using. Okay, the tasks that we have. So remove that. Play that. So it can show us the tasks that we have and whether they're running or they're suspended or whatever is happening. Okay. So let's stop at that. By adding FreeRTOS to our Cortex debug as such, here, we made Cortex debug FreeRTOS aware. And with that, we are able to debug FreeRTOS itself. I'm going to stop that there for today. I think it's really good that we've covered this. I think it's really good that we've reviewed this. Um, Happy for any questions. If you're watching this way later than after I made it and you have any questions, just leave me a comment. I see them pretty quickly. Or if not, please join the DevHeads Discord server, um, which you can find on my blog somewhere, and ask questions there. And yeah, thank you so much for attending today. This has been amazing. I'm really happy we got to do this. Yeah. See you tomorrow with what am I doing tomorrow? What am I doing tomorrow? Hmm. See you tomorrow. Maybe we deal with this adding Cortex debug in depth to FreeRTOS. Yeah, let's do that. See you tomorrow. And thank you